Hello viewers, I am Subbalakshmi. Now we are entering the second series of our videos, that is quantum mechanical model of the atom. In this video, we are going to discuss de Broglie's equation and the dual behavior of matter. According to de Broglie, every object in motion has a wave nature. Ordinary objects have very short wavelengths due to their larger sizes, so their wave properties cannot be detected. Whereas for subatomic particles like electrons, their wavelengths can be experimentally detected. Let us work out this problem to study the concept and to understand it better. The problem is, calculate the wavelength of an iron ball of mass 5 kilograms moving at 10 meters per second. The mass of the object is 5 kilograms m and v, the velocity is 10 meters per second. De Broglie's equation is lambda, the wavelength, is equal to h, the Planck's constant, divided by mv, where m is the mass and v is the velocity. The units for Planck's constant is either joule second or kilogram meter squared per second. In this video, we are going to use the second type of unit only, that is kilogram meter squared per second, since the mass is expressed in kilograms and velocity is expressed in meters per second. The value of Planck's constant is, numerical value is 6.626 into 10 power minus 34. Let us substitute in the equation that lambda is equal to h, the Planck's constant, which is 6.626 into 10 power minus 34 kilograms meter squared per second, divided by the mass, that is 5 kilograms, into the velocity, which is equal to 10 meters per second as per the problem. Now, the numerical part of the equation can be solved. That is 6.626 divided by 5 into 10. That will give the answer 0.1325. Now, the exponential part of the problem, 10 power minus 34, remains the same. Then what about units? We can cancel the common terms present at the top and the bottom. First one is kilograms. Next one is seconds to the power of minus 1. Then what is remaining is meter squared per meter. When we solve, meter will remain at the numerator. So the answer is either 0.1325 into 10 power minus 34 meter, which can also be written as 1.325 into 10 power minus 35 meter. So for larger objects, like iron ball, the wavelength is very small. It is in the range of 10 power. For this one, it is in the range of 10 power minus 35 meters, and it is neither detectable nor measurable. The second problem is, calculate the de Broglie wavelength of an electron moving at a velocity of 75 meters per second. Electron is a subatomic particle. Here the velocity of the electron mentioned is 75 meters per second. And m, the mass of the electron, is equal to 9.11 into 10 raised to the power of minus 31 kilograms. It is better that you memorize this value and keep it in your mind so that it will be useful to you during examination time. And Planck's constant value, for the Planck's constant value, the unit should be expressed in kilogram meters square per second. We had already discussed it. So 6.626 into 10 raised to the power of minus 34 kilograms meter squared per second. Let us substitute in de Broglie's equation. Lambda is equal to h. The value is 6.626 into 10 raised to the power of minus 34 kilogram meter squared per second, divided by m, the mass of the mass. For the electron, it is 9.11 into 10 raised to the power of minus 31 kilogram, and velocity is equal to 75 meters per second as mentioned in the problem. While solving this equation, we can divide it into two parts, the numerical part and the exponential part. First, let us solve the numerical part, that is 6.626 divided by 9.11 into 75. That will give rise to the answer 6.626 divided by 684. And for the exponential part, that is 10 raised to the power of minus 34 divided by 10 raised to the power of minus 31. 10 raised to the power of minus 31, which is present in the denominator side, if you bring it to the numerator side, the sign will change and it will become 10 raised to the power of minus 34 plus 31. All of you know that on further simplification, this will give the value 10 raised to the power of minus 3. And for the units, it is already discussed. We are cancelling the common terms. Second to the power of minus 1 and kilograms. The remaining is meter squared by meter. On simplification, this will give the answer in meter. On further simplification, we are getting, that is 6.626 divided by 684 will give the value 0.009687 into 10 raised to the power of minus 3 meters, or this can also be written as 0.9687 into 10 raised to the power of minus 5 meters. Here the de Broglie wavelength is a larger one. For an electron at the given velocity, the wavelength is large. Just to recollect that the wavelength of the iron ball, a larger object that we had calculated, is very small. It is neither detectable nor measurable. So we conclude that our results agree with the de Broglie concept that every object in motion has a wave nature and it is detectable only for very small particles like electrons and other subatomic particles. Hope this video is useful to you. Let us meet in the next one. Thank you very much for watching.